Here we're given a graph and asked to determine the x-intercepts and the vertical and horizontal asymptotes. First of all, we notice that here we have the x-axis, and the graph crosses the x-axis at -1, 0 and +1, 0. This time we're just going to list the real numbers, -1 and 1, the values of x where the curve crosses the x-axis. Now for the vertical asymptotes, we notice that as x increases without bound up here at the top, or decreases without bound, the graph is approaching vertical lines, approaching but not crossing. And on the left, the graph is approaching, both at the top and the bottom, the line x equals -2. On the right, both the top and the bottom, it is approaching x equals +2. It doesn't have to be on both the top and the bottom, but in this particular example it is. And so these two vertical lines are called the vertical asymptotes. And so in this case we have two lines, x equals -2 and x equals 2. We always say x equal because that's the equation of a line. The horizontal asymptote is the horizontal line that the graph approaches as x is increasing without bound or decreasing without bound, or both. And in this case it's both. So that line in our example is the line y equals 1. And that's the equation of our horizontal asymptote. So let's move to another example here. Again, we're given a graph and we're asked this time to list the x and y intercepts, this time as ordered pairs, and then the equations of the vertical and horizontal asymptotes if they exist. And so in this case, our x-intercepts are occurring at -2, 0 and +2, 0. And the one with the smaller x value is -2, 0. The one with the larger is +2, 0. The y-intercept is down here at 0, -6. This time, y does not increase or decrease without bound, and certainly isn't approaching a vertical line. And so the vertical asymptote does not exist. There is no vertical asymptote. There is, however, a horizontal asymptote. In this case, it's the line y equals 4. That's the equation of a horizontal line, and it is the line that the graph is approaching as x approaches, in this case, both positive and negative infinity.